So for this video, we're gonna work on friction and forces, as well as Newton's second law, and then we'll finish with example problem number 14. So number 13. So for this, what we're gonna do first is talk about how we represent friction as a force. So pretty much a classic problem, box sliding down a ramp. The friction is going to be in the opposite direction of the momentum of the box, or which direction the box is sliding. So if we have this as mg sine theta, friction would be going the opposite way, and then you add them by going mg sine theta minus the friction coefficient. And when you use the friction coefficient, say they give you like a coefficient of 0.2, how you'd use that is you go here's a normal force, of course. So you use friction coefficient, which in our case is 0.2, so you go minus 0.2 times the normal force, okay? So friction coefficient times the normal force. That's what you do. So and that of course equals sum of all forces, which is F, which equals ma, of course, Newton's second law. So now what we're going to do is go to our example problem. So for that, we're going to look at number 13. A skier is traveling down a slope that is inclined 30 degrees above the horizontal. The coefficient of kinetic friction between the skier and the slope is 0.10. Which of the following best describes the acceleration of the skier? So we can draw sort of like what we had before for the model, for the practice model. So this is 30 degrees. This is, here's the normal force, N. Normal force, if this is mg sine theta, the normal force equals mg cosine theta, right? This is mg, and then this is our friction coefficient. That's friction coefficient equals 0.1. So for this, all we have to do is sum our forces. So that's the symbol for sum, like a little e, or a uppercase E sort of looking thing. Sum of forces equals mg sine of theta minus 0.1 times normal force, and in this case normal force mg cosine theta, right? Sorry, I forgot the mg. There we go. So of course for this, that equals sum of forces, which equals ma. So we can use this equation. And we see that everything has m, so we can cross out m. That's the first thing we do. Next thing we can do is input our angles. So we know that the angle is 30 degrees, right? So it's going to be g sine of 30 minus 0.1 cosine of 30 equals acceleration. So we're almost there. Now we know that gravity equals 9.81, which we round to 10. So 10 sine of 30 minus 0.1 times 10. Oh yeah, I forgot the g right here. Times cosine of 30, right? Sorry, there we go. equals a. Then we can simplify this. Sine of 30 degrees is equal to 1/2. So 10 times 1/2 equals 5. And then we can 10 times 0.1 equals minus 1 cosine of 30. And cosine of 30 is approximately, it's around 0.8 or something like that. So 5 minus cosine of 30 degrees equals a, which is approximately 5 minus 1, which is approximately 4. Remember, for this problem, we don't have to be super exact because the answers are pretty general and far apart. But as you can see, our answers is 0, 4, 9, 10, and cannot be described, and it's 4, as we found through these equations right here. Here, I'll move that over so you can see. Yep, and that's our acceleration.